Okay, before we can start looking at naming acids and bases, we need to review how we write formulas and names for ionic compounds. So the first page of this activity that you're working on today it should be all review, but I'm making two short videos just in case it's been a while since you've done this to help you out. So in this first section, I see that they have given me the names of some ionic compounds, and I'm going to have to write the formulas. So for this activity, you're going to need two different reference materials. The first one is your periodic table, because for formula writing, we need to know oxidation numbers. Remember that oxidation numbers are the charge that an atom has when it either gains or loses electrons. So everything in column 1 is going to have an oxidation number of +1 because they lose 1 electron. And hopefully this is all review for you and you've got your periodic table marked up. Column 2 is going to have a +2 oxidation number. I'm going to skip over these transition metals because they have different numbers and it's always given to you in the name. I'm going to come over here to column 13. They give up 3 electrons to have a +3 charge. Column 14 can either gain or lose their 4 valence electrons. Group 15 has 5 valence electrons, so they've got a -3, -2, -1, and then our noble gases over here don't bond. So we're not going to look at their oxidation numbers. So you need to have your periodic table with your oxidation numbers handy. The other thing that you're going to need to have is your polyatomic ion chart, which is in your reference materials, because you probably don't have these memorized, and I don't either. So whenever I see a formula and I recognize that it's a polyatomic ion, I have to go back and look up its name. For example, C2H3O2 is the acetate ion. So going back to our worksheet, I'm in this first section. We are going to write the chemical formula for the following ionic compounds. And I'm going to work an example for you here and just move this over to the side so you can see it a little bit better. So I am writing the formula for calcium hydroxide. So the first thing I want to know is what are the charges on the 2 ions that form this compound. So I'm going to look for calcium on my periodic table. I find it right here. I go up to the top of the column. Calcium has a +2 charge. Hydroxide, I know, is a polyatomic ion. So I'm going to go to my polyatomic ion chart. I'm going to find hydroxide. It's right here. It is OH. And its charge is a -1. So I'm going to write the hydroxide charge up here. Now, I'm not sure how Ms. Hassel taught you guys to write your formulas. I'm going to use swap and drop, which is where I'm going to take the charges and I'm going to swap them with the different ions and I'm going to drop them down when I write my formula. So here's what that means. Calcium, I'm going to write the symbol for calcium, which is Ca, but I'm going to bring the charge down from hydroxide and put it down here. I don't move the charge, I just move the number, which would be a 1. But remember, we don't write 1s in chemistry, so I'm just going to pretend that it's there and erase that. Hydroxide, I remember from my polyatomic ion chart, is OH, is how I write the hydroxide ion. I'm going to grab the 2 from calcium. I'm going to move it down as a subscript for hydroxide, number only, no charge, and I'm going to get 2. In fact, let's write this correctly and put that in parentheses because I have 2 hydroxide ions. Each one has an oxygen and a hydrogen. So now I'm going to go back over to my worksheet that I'm working on, and I'm going to write that over here. Calcium hydroxide's formula is Ca1, that I don't write, OH2.